Okay, it's about time for us to now continue and let's do that. So we're going to keep going with this same notebook we've been using, the functions notebook, where we've introduced earlier the idea of how to define our own functions and use them. And the next step here is to now consider what happens when we have several functions we want to use in a notebook, for instance, and we don't want to clutter up the notebook with a bunch of cells full of functions. And for this purpose, we're going to introduce the idea of a script file. This is actually the more typical way in which Python code was written prior to using notebooks, but notebooks have become very popular in data science and other fields. So that's what we're now introducing here. Inside of our Jupyter Lab session, it's possible to create a script file where we can list several functions, and then we can use the functions out of that script file inside the notebook. But the first step here is to actually start to create our script file by going up here to File in the Jupyter Lab toolbar to New, and then going down to the bottom to Python file. So you can just click on that. And what you'll see is this creates an empty file here, just doesn't have anything in it, called untitled.py. So here, just in case you didn't follow that, you could find the steps for creating a new Python file in the notebook. Once you've created the file, so again, just File, New Python file, you can take the text here. They have this definition of our Celsius to Fahrenheit function. You can just copy that. Going to click over here to the tab for untitled.py, paste that in here. You'll see that the syntax highlighting shows up. It recognizes it's a Python file and colors things just like we see in the notebook. And then we have, included our function now inside of our notebook. One thing, if you haven't noticed it yet with these notebooks, is you can actually click on the tabs and drag them around to rearrange things in a way that might be more convenient for you. And in this case, what I'm going to do is I'm going to click this untitled.py tab and drag it down so it fills in the lower half of my screen. So I'm just going to drop that there. So now in the bottom half, I can see my untitled.py, and above I can see my functions notebook. This will be helpful as we go forward here. And just so you know, you can also click if you want and move things around to sort of change the balance of how much is visible of either of the windows. So I'm going to make this a little bit smaller for the untitled.py. So we've copied and pasted now our function name in here. And the next step is to rename the Python file, because untitled.py might not be what we want, but instead we're going to call it temp_converter.py. You can rename it by going to where the title is on the tab. And if you right click there, you can then go to rename Python file. I think you can actually do the same thing over here in the file browser as well. If you right click on that, there's an option to rename in the file browser as well. How do you copy and paste it? When I do it, just get weird numbers. Copying and pasting in the notebooks, I think if you just select the text and then right click on that and do, there's no option to copy like that. For me, I guess I'm using the keyboard shortcuts. So I was just doing on a Mac Control-C, or Command-C and Command-V. If I'm not mistaken, on Windows machines, you might have to do Shift-Control-C. Maybe somebody wants to confirm this, but I think you have to maybe hold the Shift key when you do Control-C. And then when you go over to where you're going to paste it, someone just saying it's just Control and then C. But I think, there was something in years past where people have had some issues with copying and pasting in the notebooks. If you were to go select the text, I think you can also go up to edit and then copy And it should be the case, if I just delete what's here, that I could then go to edit and paste in the web browser's toolbar. No, so that doesn't seem to work. When I tried to copy it here, edit, copy, edit, paste, doesn't seem to work. So yeah, it's selecting the text and then Command C on a Mac or Control C on Windows, and then Control V to paste it. Okay, good. So that's been copied and pasted. Now we need to rename this. So as mentioned, if you right click on where the tab's name is, you can go to rename Python file. If you click that, it pops up a little dialog box here where you can just type in temp underscore converter, temp converter. So this will be our name of our Python script file for converting temperatures, an intuitive name, temp converter. Then you can click rename. You'll see the file name changes now to be temp converter here and in the file browser. So all looks good at this point. And you just want to make sure that if you click on this tab, you could do Control S or File Save to save the contents of that file after making the change. Now, in order to use our functions, let's first copy a couple other things here. Let's copy the other functions we've defined at this point. So Kelvins to Celsius and Kelvins to Far. Let's copy those in here to our temp converter and paste them in like this. So I just copied those with Control C or Command C and pasted them. And again, I'll do on a Mac, Command S. I think you can Control S to save the file in Windows, but now that's saved my functions inside here. There's now 3 of them. How do we use them? Good question. In order to be able to use them, we first need to figure out, are we in the directory where our functions in our temp converter file have been defined? So there's a magic command, as it's called in IPython, called %ls. ls would normally list files in the Linux or Unix-based operating system, but %ls will do that same thing in IPython, which is running under the hood in a Jupyter Lab environment. If I do %ls and run the cell, it will list the files that are in the directory where I'm working right now. So I can see, for instance, tempconverter.py. All looks good there. If you're using Binder, you might see a different list of files, or if you're on the CSC notebooks, it's possible you could see something like exercises and notebooks there, in which case you would then type %cd notebooks/L4 to end up in the directory where you should be able to see the tempconverter.py file. I can already see that, so I'm going to continue along from there. But if you're having problems, you can say something in the chat. If you don't see your temp converter file, perhaps Hovard can give you some guidance there. So we can confirm we're in the right directory. Well, there's no need to do that. I haven't changed directories, but sure enough, I see temp converter is here. So let's make our temp converter functions available for use. And we can do that by importing them. Just like we would import another like library or module, like the math library, we can also import our functions we've defined in our temp converter Python file. In fact, that's basically how these libraries are working in Python and the modules are working. So let's do an import here. So from temp_converter, this is one way in which we can import things. Import, and let's call Celsius to far as the function we want to import. So it's going to look for a file called tempconverter.py, and inside that file, it's going to look for a function called Celsius to far and bring that in so that we can use that. So I run that, and now we should have a Celsius to far function that we are able to use. So we can do things like print, let's make it an F string. So let's print the freezing point of water in Fahrenheit is Celsius to far. we've done this before, so you don't necessarily need to do this. But the freezing point of water in Fahrenheit is, and then again, we're doing an F string, so we put the curly braces around the value we want to have filled in here, Celsius to FAR of 0. We've run that. The freezing point of water in Fahrenheit is 32. Yes, we get the output we expect to see here. In this case, we are using the Celsius to FAR function we have imported from our temp converter that's defined right here in tempconverter.py. If you wanted to do take multiple functions from some script file, you could say from whatever the name of the file is, import function 1, function 2, function 3, just separated by commas. Not necessarily the recommended way to do it, but you can do things that way. But what's better in some cases when you're working with multiple functions from a single file, and maybe when you don't want to have possibly other functions with the same name interfering with this, is you can bring the whole script in as we can show here. So in this case, if we type in import temp converter as TC, we're going to read in this script and make all of the functions that are part of it available inside of the TC. There's a question here in chat. If we'd like to convert Fahrenheit to Celsius, can I just reverse and then the function? If you wanted to convert Celsius to Fahrenheit, I mean, I would probably, just for transparency, I would probably define a separate function for doing that. It depends a little bit. I mean, mathematically, yes, you could potentially take what you have done in the function and do the opposite of that. Like here, you've got, return 9/5 times temp Celsius plus 32. You could take the temperature Fahrenheit minus 32 and then multiply that by 5/9, which would give you the temperature in Celsius. I think for code readability, it's a good idea. Maybe like if you did that inside of a function, no one would know, but I would have a separate function perhaps for doing that. Like I would make my own FAR to Celsius function that does that. On the interior of the, like what's happening inside the function, it may not matter so much, but yeah, for readability, I think you'd want to have your own function for that. So yeah, importing from the script then, yeah, again, what we're bringing in here is our whole temp converter script is TC. We're going to rename it so that we can access all of the functions by typing TC dot and then some function name. So let's import temp converter as TC, which means that then we can do things like print. And let's say make an F string here. Absolute 0 in Fahrenheit is, put the curly braces again, TC dot kelvins to bar. And then the value we want to convert in this case is temp kelvins equals 0. So in this instance, we have our kelvins to FAR function defined here in this script called tempconverter.py. We read the entire script in, and we just, to make it easier to access, refer to it as TC. So it reads it in. Instead of having to type in tempconverter.kelvins to FAR, we can just type in TC.kelvins to FAR. So TC is the name of what we've imported as our script. This is the name of a function in that script. And if you run this, you get absolute 0 in Fahrenheit is the same thing that we saw previously. There are a couple other examples on the course page you can see, but that basically do the same thing. But this is the recommended way if you have multiple functions you want to use from a script to bring them in, is to import them as temp converter or whatever the name of the script is, and possibly rename it if you're going to use them many times. You might want to give a little bit shorter name to be able to refer to those functions more quickly without having to type in so much. Are there any questions at this point? There is a little bit more in the functions lesson that we won't go through about this temperature calculator. So this is combining some of the things we've seen already in this lesson and earlier in the course to allow us to have a function where we can specify a temperature and then what it should be converted to. And so you can see in here some additional things that are done in defining the function and then how to use it. So if you'd like, you can check the course page for how to do that. I won't go through that in any detail here because it's going a bit more beyond what we've already covered. But if there aren't any questions at this point, I suppose it would be good to let Håvard talk to you briefly about modules and how to interact with modules in Python. So I will stop sharing my screen. And yeah, let Håvard take over.
Yes. So I will be in the L4 folder in the modules notebook. I will be iterating a bit about using modules and packages and libraries in Python. And so the modules and packages and libraries are words that you will hear quite often or read quite often in Python. And these words are used interchangeably. But the main concept is that Python modules refer to Python code that is designed for a specific task. And technically, these Python modules are script files, just like the temp converter.py file that you just created, which contain many different functions usually. So modules and packages or libraries contain a lot of different code for specific tasks that can be imported and used in your own programs and notebooks and scripts. And you have already been introduced to loading packages and modules already, but I'll go through it step by step here as well. So one example is when doing mathematical operations, you would want to use mathematical functions, and like if we want to calculate the square root of a number, we would use the math module. And one way we could do that is by import math. And if we run that cell, as you know, we will then import the whole math library or module. And then we can run by typing math.sqrt for square root. We can run the square root function that is within the math module. So here we loaded in the module and then used the specific function from that module in the math module. And you've also been introduced to a lot of the built-in functions in Python, such as print, that we use quite a lot. And if you go to, if we click this link and go to the documentation on the Python website, you can see all the different built-in functions. And technically, in a way, all these functions are functions of the module that is built in. So here you'll see some that you are familiar with, like print and range and len. And these are all kind of functions that are in one module called built-ins. Okay, So the next step that we can do is, as Dave also did before, is we can rename our modules when we import them. That is to, if the modules have long names, we can make them shorter so that they are easier to both remember and use and doesn't require that much typing in the programming. So we can start with importing math and shortening the name by using the as keyword and then the new name that we want to use. So for example, we can import it as m, and then consequently in our notebook, then if we type m, that is the same as math, and then we can get the square root function from that, and if we run that, that should also print out the 3 as the result. And we can also test this to see by what m is by running the built-in function type and pass it on m. If we run that, we will see m is a module. So for math, that's maybe not the best example, as that is quite a short name to use, but later on you will be introduced to other packages and libraries such as pandas, for example, which we will use in later weeks for data analysis. And a very common way to import pandas is to import pandas as PD and then subsequently use PD and then the functions from pandas that we want to use. Okay, I hope that was clear so far. As Dave also showed you with our temp converter, we can also import just one single function from a module, and that the way we do that is by typing from module and then import and the function that we want to import. So for example, from math, import square root, then we can just use square root subsequently to calculate, to use the square root function. Then we don't have to type math. Yeah, so this is a method that can be useful, but if a function of a module, for example, has a name that is already used in Python from the built-in function, for example, you'll get into issues where that doesn't work because you can't import, for example, print as a new function since there already is a built-in function named print. Yeah. But another way you could also do, if you want, if you add another cell here, you can also import one single function from a module and rename that. So we could from math import square root. If we think that is a too long name, we could use sq as well. Yeah, and then use that in the next square root 9, and that gives us the same thing. So that's just following the same recipe using from module import function, and then if we want to, we can rename that as something else. And the same goes for submodules. So within a module, you can have, or in a library or module, there can be a lot of different functions, but there can also be submodules. So modules within the module that have a lot of different functions. And that is, for instance, the case with a library that we will be using later on in the course called matplotlib, which is a plotting library. So within matplotlib, there is a submodule called pyplot, and it's it is customary to import that as PLT, as written here. So matplotlib as PLT. Just to give you an example, the reason why we might not want to import the whole matplotlib library is because that is very large. And then we only need the pyplot submodule. And then it's good practice to import just the things you need and not everything else. So that's why here we import only matplotlib.pyplot. So the dot indicates that here is a submodule that we import. Yeah, and then an example of using the matplotlib library, we can give it type PLT, which is the name we renamed pyplot as, and use the function plot and pass it a list of x-axis values and y-axis values. And then that will produce a line chart in this instance. But you'll learn more about plotting in the following weeks. So one thing that can occur when you are importing libraries is that you don't necessarily remember all the different names of the different functions within that module. And one of the ways you can find the different names is within Python. You can type print and then dir, which is it lists the directory of all the functions that are within the math module. So if you run this, you will get just a list of all the different functions, which is might not be so intuitive, but at least you can get a list of that. But also in notebooks or other Python use math, and if you start typing and then press tab, you will get a list of the different possible functions in the math module. So there we can see square roots that we can run. Another way to get what the functions do after you've imported the module is with the built-in function help, and then the function that you want to look at, what does it actually do. Then if it's described in the documentation of that module, we can here get information about what the function does. Okay, I hope that was clear. So lastly, some things that you should try to avoid when importing packages. One thing you should try to avoid is importing, or with this this wording, from X module import and then the asterisk. That in that case you import everything, all the functions that are in that module. So that can be that can be a lot of functions that you don't need, and it will bloat up your program and make it slow. Yeah, and so and also avoid trying to use bad names when you're renaming on import. So like importing matplotlib as m. When you're also trying to import math as m, you will get conflicting values. So make sure that the renaming you do is unique and also logical, so that you understand instantly that this is what it refers to. And then as you will experience going along, that you will see that there are some common ways to import modules, like pandas imports as PD is very common to do. Yeah. So yeah, like you could, for instance, type import matplotlib as math. That would work in Python, but you would be getting into a lot of problems because math is also another library that you will probably use as well, and then things will get messy. Yeah. So in PEP, the PEP 8 guidelines that we talked about earlier, there are also some guidelines on how to import different modules. And in general, the main rule is that you should import all the modules that you need in the top of your script file or in the first cells of your Jupyter notebook, because then all the modules get loaded first, and you get either see if you're some packages that are missing that you don't have on your computer, and you can also see everything that everything that you need during the script following that. And for those of you who are interested and maybe are using Python and JupyterLab on your own computers, on the course web pages there are some instructions for how to do that, and we recommend using the conda package management system. That makes it easier to manage all the different packages and libraries that you are using, and then using that there's also a way to see what packages you have installed. And for example, if we open a terminal here, we can, I'll just drag it to the bottom here as well. Then by typing, for example, conda list, you would get a list of all the different packages that are installed on your system. And there are usually a lot of different packages that depend on each other, so there's a lot installed, but you will also see some that you might be familiar with, like pandas here, and numpy. So when you can see the name and the version number that is being used, and also which channel on conda that it is installed from. So if you want to use it on your own computer, it's good to have an idea of what version of different packages are installed and used, because there might be they might work differently in different versions. If you just want to use it or on the JupyterLab that on CSC that you are running, we have already set up all these different packages to make sure that everything that we need in this course is installed. But you can play around with on your own computer with conda and installing different packages if you want. So yeah, and then that is basically it for modules and libraries, I think. So in short, the modules are just a bunch of, it's a kind of a script file with a bunch of functions, like the Temp Converter .py, the script we already wrote today, that you can import into other notebooks and programs. Yes. So if there are any questions relating to that, we could take that now, but I don't see any. So then maybe Dave will take over again.
Yeah, I don't see any questions either. So thanks, Håvard, for the overview of how to use the modules. And again, as we're going through the later parts of the course, we're going to be using things like pandas regularly, matplotlib, and others. So you'll get plenty of experience with how to load and use modules. So I do think that this is that part of the lesson is quite nice for showing you some examples of what not to do, because occasionally if you import modules in a weird way, you can end up with very difficult to understand code. So there's some good recommendations there for how to avoid those problems. But I will share my screen again here, and I'm just going to now cover our last couple things for today's lesson. So one of them is we do have a good coding practice for this week. I'm going to get rid of that temp converter for now. The good coding practice for this week relates to script files and writing our scripts in the quote unquote right way. The right way in this case is basically just a few tips for how to make your script easy to read and to include all of the elements that should be there to help yourself and other users understand what you've done. As we've already mentioned in some of the earlier lessons, you can add comments to your code, such as inline comments. Those are starting with the number sign or pound symbol, whatever you want to call it, hashtag thing. And that definitely is helpful in explaining what your code does, but at least there are some ways you can even improve on that. So here's our example. We have some kind of variables that are defined with some comments that are describing what they do, but it's all kind of clustered together in a way that makes it a bit difficult to read. So one of the tips you can use already is, in addition to including these inline comments, you can use white space or line breaks wisely to separate things a bit, to make it easier to read. So here we have some line maybe at the top of a script file that explains what's in this script file. Then we have some inline comments that refer to specific values, and those values are then listed directly underneath that comment with a line break in between. And so when we're going then to using a print statement here, probably should have updated this to use an F string, but when we use the print statement here, then everything is separated out in a way that makes it easy to read. So that's one of the tips that's shown here. Another tip, and something that we'll expect you to do in this week's exercise, is to use a docstring. And a docstring, there's one example that's shown in the functions lesson down in the advanced topics. But a docstring is basically a little block of text that is started by usually triple double quotation marks. So that's a bit confusing, but 3 of the double quotation marks is the typical way to indicate you're starting a docstring, and it usually ends with triple double quotation marks as well. You can use single quotes here as well. That works as long as there's 3 of them in a row. It will work either with single or double, but one of the PEP recommendations about documenting functions and things like that suggests using the double quotation marks. I like the way single quotation marks look personally, so I tend to use those, but it works the same either way. The thing is that anything between the triple quotation marks will be seen as a comment, and if it spans multiple lines, all of that text will be commented out. A docstring would typically be placed at the start of a file or at the start of a function, and it would then describe what that file contains. So here we have several lines describing what this file is about. So if this is a script file, you would see that you could actually run the help command and then the name of the script file, and it would print out this information here. So it would tell us what the function or this script does. So it prints information about an FMI observation station to the screen. So you can see a little bit more about that if you take a look at the course page, but we're going to ask that you use these kind of docstrings inside of your functions this week, and they can go directly under the function definition as is shown in the example in the temp calculator here. If I scroll down just a little bit, you can see this is a little bit of a longer example of a docstring, but the docstring is defined right after the function's definition with triple quotation marks, and the text is indented, and then you should say what the function does. But you can do the same thing for a script file if you put it at the start of the file. It's also possible to include a license. This might be something if you're sharing your software that you want to do, if you're sharing your Python codes or your notebooks. So you can always put inside the docstring, for instance, a license, or maybe you have a separate file called license.md. It's a kind of typical name for a markdown file that contains the license that states essentially how the software is meant to be used. An MIT license is just one type. There's lots of places where you can find information about licensing your software. There's a website, I think it's choosealicense.com, that will allow you to basically use a little selector thing to say what are the cases you want and what are the restrictions you want to have on your code use, and then you can choose the license that corresponds to that. MIT licenses are fairly open, which basically just says that you're free to use the code, but the code author takes no responsibility for what the code does. So that's including a license. And then finally, there's this starting out with a shebang. So maybe you've seen, if you've looked at Python scripts before, this weird set of characters at the beginning with this sort of number sign or pound sign and then an exclamation mark. And then what's typically given after that is either a file path to the Python executable, or in this case, it's a file path to the env variable and then the name of the Python executable. Oops. And in that case, that's essentially allowing it so that you could make your code, your script file, be executable directly inside of a terminal window. We won't talk about that too much, but you can look, for instance, on Wikipedia if you're interested to know more about what this shebang starting thing does. So we're going to mainly be working in the notebooks. So this stuff is a little bit, maybe of limited use in the course, but it's still nice to know things about how to use doc strings, and they can be quite helpful in describing your functions and how they should work. So please take a look through this good coding practice for this week when you have a moment. But yeah, now I think I've hidden the chat, so let me make that visible just in case there are any questions. Now what I'd like to do is just give a preview of our exercise number 4 for this week, and then if we have a little time at the very end for questions, we can do that. There are 3 questions in this week's exercise. As you might expect, it relates to functions. And as always, it's due a week from today. And the one thing that is notably different from the previous exercises is that we are asking you for some midterm course feedback in this week's exercise. So problem 0 is to go here and fill in some course feedback. Essentially, it's helpful for us to know how things are going and make adjustments to the course on the fly during the final few weeks of the course. So if anything is really being problematic, it's good for us to know about it now. And it's totally anonymous. You're not asked in any way to sort of identify yourself on the forum. So you can give some honest feedback, positive or negative. We don't take these kind of things personally. It's just good to know how things are going and how you feel about how the course is working. So please, as you do the exercise this week, take a few minutes and just go fill in the course feedback form. It shouldn't take too long. And this midterm feedback is really useful for adjusting things for the remaining parts of the course. Next week, we'll start the class by kind of going through the summary of the feedback. So this will be, I think, the feedback form is open until midnight. So end of the day on Tuesday next week, so that then on Wednesday morning, we can compile the feedback before class. All right, 3 questions. I am going to open them in separate tabs here, just so that we can see them easily. First question is to make a temperature calculator. So we have in the lesson done things like converted our temperatures from Fahrenheit or from Celsius to Fahrenheit. Now we're going to do the opposite, which is to convert a temperature in Fahrenheit to a temperature in Celsius. And so you're asked in this exercise to create a function to do that, such that you could run the following statement here: print 32 degrees Fahrenheit in Celsius is, and then call your function far to Celsius with that value and get the output that it's 0 degrees Celsius. I think this is fairly straightforward in terms of what you need to do here, but basically you should just pay attention when it asks you, for instance, to define a function named far to Celsius, that you use exactly that name and that you use exactly the name of the parameter that you provide, temp Fahrenheit, just so that when the automated grading happens, it doesn't choke on things like that. There are some tests here that will also check to make sure you've used the correct variable names. So that is the first problem, basically just doing a temperature converter. Problem number 2 is here. This is combining a little bit of what we had done in last week's exercise with classifying temperatures, and that is to make a function that we can use as a temperature classifier. So the way it should work is that based on the temperature you provide into it, if the temperature is below -2 degrees Celsius, it should return a value of 0. If it's warmer than -2 or equal to -2, but less than +2, it should return a value of 1. And if it's equal to or warmer than +2 and less than 15, it should return a value of 2. Otherwise, it should return a value of 3. So you'll be creating a function here. And again, you'll have some tests to see whether your function is working properly. But basically, the idea is to create this temperature classifier so that if temperature is provided in Celsius, it gets a value that comes back as either 0, 1, 2, or 3 to classify the temperatures. The final problem for the exercise this week is to use both of the functions we've just created. So we're going to apply the classifier. What that involves in this case is to create a new script file called tempfunctions.py, and you're going to put the functions you created in problems 1 and 2 into that script file. You can add a doc string to the script file and doc strings to both of your functions if you haven't already done that. And so you're given some instructions how to create that script file. Once you've created it, you're going to import the functions from the script file into this notebook and use those functions to classify a list of temperatures here. So this is temperatures every half an hour in degrees Fahrenheit for 1 week. I don't remember where the location is here or which month, but anyway, we've got our temperature data there. You'll bring in your functions from your tempfunctions.py script, and you're going to create a list called temp classes and then classify these temperatures in terms of how many fall within the different bins when converted from Fahrenheit to Celsius. As you do that, you'll then end up with a list of a certain number of values where your class is 0, class 1, class 2, and class 3. And then there's some tests here that check to make sure that you have done things properly for this point. So then you'll see when you run the code, for instance, at the end with these tests, that you can print out the numbers of 0s, 1s, 2s, and 3s. That is basically it for the exercise for this week. So you're creating a couple functions, then you're putting them into a script file and using the script file to classify some temperature data in a list that is provided to you. Are there any questions at this point? I'm not seeing anything at the moment in chat. I think, yeah, I think we've pretty much covered what we have for this week with our introduction to functions and then a bit about how to use modules and script files. I'll remind you that it's very helpful if you don't mind to provide us with the midterm feedback as part of this week's exercise. That would be very, very nice. We certainly appreciate it. And beyond that, sign up for a time in the exercise sessions if you want to join those in person. There should be space based on the previous weeks, but note that the exercises will be getting a little bit more challenging perhaps in weeks 5, 6, and 7. So you may want to think ahead and be ready to reserve yourself a time there if you're going to need some assistance with the exercises. And next week, we're going to move on to talking about how to do some basic data analysis using a library called pandas that we've just saw very briefly in what Hofard presented, but we'll get introduced to pandas next week, start reading in data from files and then interacting with that data using Python. But yeah, I think that's it for this week. And if you have any questions, myself and Hovard will stay on for a few minutes here in the Zoom session. Otherwise, good luck with the exercise this week, and we'll see you in the exercise sessions.